Hello friends, welcome to one more video of CS Technology. This video is part 3 of Viva questions on data structures, and in this video we will focus on stacks. So let's begin. Before jumping into the stacks, you also need to understand what are data structures. So the data structures, arrays and linked lists all are explained in our previous videos. So please refer part 1 and part 2 of our Viva questions. So let's begin. What is stack? What is a stack? A stack is a data structure that works based on LIFO, which is last in first out order. What it means is the last element inserted in a stack will be the first to remove. So how is stack implemented using a linked list and an array? This could be some common questions. So let's see how do we implement it using a linked list. So each element of the stack is represented by a node of the linked list that contains the element's value and a pointer to the next node. So this is the general linked list. The addition and removal will be only using the head node or the first node of the linked list. How is stack implemented using an array? A fixed size array is used to store the stack elements and a pointer keeps track of the top of the stack. So what are the time complexity of stack operation? So it is generally O of 1. Why? Because all the operation which is push, pop and peek take the same amount of time to execute irrespective of the size of the stack. Right? The size of the stack doesn't affect the time complexity because you are doing all the operations at only one end of the stack. So what are the operations that can be performed on stack? So push, pop, peek or top is empty. You can check whether it is empty or is full in some of the programming languages, and you can also check the size. So what is each one of them? Push inserts an element onto the top of the stack. Pop removes and returns the element from the top of the stack. Peek or top retrieves the element from the top of the stack without removing it. It is just like read, right? Is empty. Checks if the stack is empty. Size returns the number of elements currently in the stack. In addition to the previous basic questions, there could be one question more from an implementation perspective. This question could be how to check if given expression with parenthesis is balanced or not. So here the examiner may give you an expression like this and can ask you to simulate it, right? Or trace it. So what we need to do, iterate through the expression from left to right of this expression. If an opening parenthesis is encountered, push it onto the stack. If a closing parenthesis of same type is encountered, check if it matches the top of the stack. If not, the expression is not balanced. If they match, pop the top element from the stack. After traversing the entire expression, if the stack is empty, the expression is balanced. What it means is, for example, if you have encountered the square parenthesis, right, you will keep on inserting it into the stack and you will evaluate the expression. At each time you encounter a similar type of parenthesis, you will pop the previous one, right? So for example, you have encountered a parenthesis here, you will pop it when you encounter this one, right? So at the end of this entire evaluation, if the stack is empty, it means the expression is balanced. What are the applications of stacks in programming? Function call management. It is used to keep track of the calling order and local variables. Expression evaluation, evaluating arithmetic expressions using postfix or prefix notation. Undo or redo functionality in text editors, for example, Microsoft Word or PowerPoint, right? So whenever you undo or redo, stacks can be used. Backtracking algorithms such as depth first search, right? Compiler parsing, used in parsing and evaluating mathematical expressions. So how does stack memory work in programming languages? This is a very important question. Stack memory is a region of memory used for storing local variables, function calls and return addresses. When a function is called, its local variables and parameters are allocated on the stack. As each function call is completed, its stack frame is removed from the stack, allowing the previous function call to resume execution. What it means is that, for example, there is one function call, one function can call other function. So each time a function is called, there is an entry into the stack so that at the end, when you have to when a method or a function called returns, so then you will keep on popping the existing stack to ensure that which is the previous function call. So what is the significance of LIFO, that is last in and first out property in a stack? The LIFO property ensures that the last element inserted into the stack is the first one to be removed. So this property allows stack-based algorithms to efficiently perform operation such as function call management, expression evaluation, and backtracking. So this diagram illustrates how a stack operates. So you can see that insertion and deletion happens from only one end, right? The other end is not allowed. You can see that the element 1 is pushed, element 2 is pushed, and the most recent element which is pushed will be the one which will be removed. So the insertion is called as push, the deletion or the removal is called as pop. So I hope you liked the video so far. If so, please like the video, share and subscribe to our channel CS Technology. So there are other questions on Viva on arrays as well as linked list. Please refer them. Thank you.